Hi, this is analysis of algorithms. We're doing the homework for chapter 3. As always, you're supposed to do the homework first and then you check your answers here. Okay, a few small problems and then we'll go to the Excel. 3.1-3, it says as follows. Explain why the statement, the running time of the algorithm A is at least O of n squared. Is at least O of n squared, why this statement is meaningless. Okay, so let's just look at this from what we said before. This is n squared. O of n squared is all this. Okay, now listen to what the words, at least O of n squared. O of n squared means all these things. These down things that grow the same speed as n squared or less, including the constant. Constant functions grow much slower than n squared. The point is as follows. It's meaningless because if it grows at least O of n squared, so that means it's anything in here, at least, that's the bottom bound. But this is a bottom bound. Okay, so it doesn't make sense. It's like saying, because at least O of n squared, this is O of n squared, constant, and saying at least that means it's higher than that, or it's higher than or equal to. So it doesn't make sense because it could be anything. It's saying, it's just similar to saying Jack is at least taller than less than 3 feet. Okay, it's the same sentence. At least taller than less than 3 feet. Well, if you say at least as tall as 3 feet, that means he's taller than 3 feet. But he's at less than 3 feet, and that's what that O is, less than or equal to 3 feet. Okay, he's at taller than at least 3 feet. That sentence doesn't make sense. Okay, so that takes care of that. Let's do the next one. Okay. Okay, you want to know, is 2 to the n plus 1 equal to 2 to the n plus 1 equal to O of 2 to the n. Okay, and you can do this by just plugging it into the formula. Limit as n goes to infinity of 2 to the n plus 1 divided by 2 to the n. Okay, so this is n plus 1 copies of 2, this is n copies of 2. If you cancel it out, okay, basically this cancels out with this, and you're left with 2. And so, yes, it is. And the way to see this is basically, this is just simply 2 times 2 to the n. Okay, so it's just this function, 2 to the n, multiplied by a constant. So it's the same thing. So it's not even an issue. Okay, the other one is 2 to the 2 to the n. I'm sorry, 2 to the 2n is O to the 2n. Okay, let's do another one. 2 to the 2n equals, question mark, O of 2 to the n. Okay, and what this is 2 times n, and this is n, so this, we'll do it again in terms of limits. N goes to infinity of 2 to the 2n divided by 2n. If you want, this is equal to 2 to the n times 2 to the n. You add the exponents, you get 2n, okay, divided by 2 to the n. Anyways, cancel this out with this. That, when n goes to infinity, is equal to infinity. So this is equal to infinity. So that's not true. This is not true there. It's not equal to. It's much bigger. This grows much bigger than this. Okay? This would have to be a constant or 0 for this to be true. Okay, let's do the next one. This is 1.7. Okay. O of g of n, little o of g of n, intersect omega of g of n. We want to show it's the empty set. Okay? I'll do this a few different ways, but the idea is, here's one idea. This is g of n. This up here is omega of g. This down here is O of g. Okay, these are things that grow slower than g. These are things that grow faster than g. These are things that grow the same speed as g. Okay, but if you're growing slower than g, you're not growing faster, and so the intersection is 0, the empty set. Let's just do it another way. This is all those things, the limit of n goes to infinity of f of n over g of n is equal to 0. This is the limit of f of n over g of n of n goes to infinity is equal to, these are things that grow strictly faster than g, and so this is infinity. Okay, so there's no function f where when you take the same limit you get 0 and you get infinity, so it's 0. Okay, it's the empty set. There's no function that satisfies it. Okay, next. Okay, 3.2-3. Okay. Prove that n factorial grows faster than 2 to the n. No, hold on. 2 to the n. Okay. Now, there's a lot of fancy calculus that you can do here and whatever. So I wrote on the homework, I said give the intuition. And the intuition is very simple. This is 2 times 2 times 2 times 2 times 2 n times. This is n times n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1. Okay? Now this also has n factors. There's n numbers in here, there's n numbers in here. But if you look at it, except for here, this is a 1 and this is a 2, all these numbers are 2 or larger. Okay, so here's all 2's and here's larger than 2. And the point is, these numbers grow much faster than these numbers. Okay, these are all constants. These are all numbers that are larger than 2, so it works like that. Okay. In contrast, the next thing happens. 2 to the n grows slower than n to the n. Okay. I'm sorry. Let me. N factorial grows slower than. Sorry. Let's do this. Okay. So this grows faster than this. N factorial grows slower than n to the n. Let's see why. It's the same intuition. This is n times n minus 1 times n minus 2 times times 3 times 2 times 1. This has n factors. Okay. In contrast, this has n factors too. Here are what the n factors are. N times n times n times n times n times n. Okay, so notice how this works. Here are n factors also. There are n copies of n. You're multiplying an n, so you get that. N factors. Very nice. Here there are n factors, but look at this. All of these are n. All of these are, this one's n, but this is n minus 1, this is n minus 2. These are smaller. So these numbers grow smaller than these numbers. These numbers grow faster than these numbers. The main point they're trying to show you is on the long list of things, okay, you're going to have 2 to the n is higher than any polynomials. Then you're going to have n factorial. And of course there's a lot of things in between here, and then you're going to have n to the n. And then of course you're going to have n to the n to the n, or n to the factorial, or n to the n to the n, or something like that. There's a lot more things. But this is the basic order of all three of those functions. Okay, great. Okay, the last homework problem was problem 3.3, which basically tells you here are 30 problems, 1, 2, 3, 4, 5, 6, times 1, 2, 3, 4, 5. These are 30 functions, and what they want you to do is grab a bunch, well, order them, okay? In the homework I told you just grab 5 random ones, okay? And see how they grow. They're very strange functions, and it's very counterintuitive. Some of them are easy, like n and 2 to the n, so you know that 2 to the n grows faster than n. But n to the third grows faster than n. You know some of them. But what we want you to do is do some of them like that. Anyways, so I did that on Excel, and I'd like to show you what I did. Okay, so that takes care of that. I'll connect it to the rest of this video. Anyways, I just want to say thank you very much. Take care. Hi. So this is, I picked these 1, 2, 3, 4, 5, 6, 7, 8 problems, okay? And I want to do it in large numbers. So I just simply typed in these numbers, okay? You probably should go larger than this, but that's not important. Here I picked out 7 functions, which I thought were, you know, not easy and not hard. Just pick 7. You only have to pick 5 of them. Okay, I want to show you a few of them, how they work. Okay, so I'm going to recopy it. I'm going to paste it. So let's do it. So let me just do this one. Okay, so this is equal to. Okay, I just want to show you how Excel works. I'm not teaching you Excel, but basically this is logarithm, okay, of what? Of A15, that's that box, okay, nope, sorry, of factorial of A15. Now, what base is logarithm? So this is log base 2. So you do that, comma 2, and enter. Okay, and that gives you this. Okay, good. Once you have that, you do it once. You have that formula once, and the rest you simply copy. Okay, and paste. Okay, so that's where I'm getting that. Okay, in contrast, this one is log of n factorial. So let's do that. So this is equal to factorial of log of A15, that's this box, okay, comma 2, because base 2, close parentheses, and you get 1, okay, I'm getting the same things over, okay, and then paste, and you get it again. This one's pretty simple. N to the third, let's do it because it's pretty simple. Okay, so this is equal to A15 raised to the third power. Okay, you do it once, you copy, and you paste. Simple. Let's do that. Let's do natural logarithm of natural logarithm. Okay, so let's do this. This is equal to, oh, I'm sorry, so let's put the, I don't know what happened here. let's just redo that again. Copy, paste. Very good. Okay, so this is, okay, so this is equal to ln of A15, close parentheses, close parentheses. Natural logarithms has their own functions because it shows up so often, and you get nothing there. But that's because you're, okay, and you paste the rest, and you get, by the way, these are very small numbers. Even this is million, billion, 1 billion, the output is just 3. Okay, so that takes care of that. Okay, so you can do all these things. Let me just go quickly what these functions are. I'm sorry. Let me just do it like that so you can see how to generate these functions. So, not hard at all. Not an exponential. This is square root raised to the log. This is n to the third. 2 to the log. Not hard at all. Okay, now I want to erase these. Delete that. And now I want to look at the numbers and see which ones are faster and which ones are slower. Okay, so I suspect this is the slowest. Okay, so let's put this here. Oops. Copy. I'm going to make a listing of this from fastest. So here's the slowest. Okay, let's see what's second slowest. These seem pretty slow also. Copy. Paste. These are just numbers. We didn't get into scientific notation. Good. So we did this one. So we make a V over here because we did this one. We did this one. Make a V over here. Okay, let's look at some other slow ones. This is plus 09. So this one's pretty slow also. So I'm going to copy here, put it over here, do that. Oops. Make a check mark over there. Okay, what else? Okay, these get so large because they're factorials. They get so large that Excel can't deal with them, which is fine. But this ends up at 27. This ends up at 30. So I think this is the next largest. So we'll put this here. Copy. Paste. Okay. I don't know why that's a 0. 1 to the third power is a 1. I don't know why they're giving me trouble with that, but that's fine. Okay, so this is checked. Okay, next. This is checked. Okay, and the next thing is this. Okay. And then the next thing, so this is checked, okay. Of the 3 things that are left, this is the only one that has scientific notation at least. Copy, so we'll do this. And, okay, what's bigger, this or this? It would seem to me that this is bigger. Look at this, by n is equal to 100, this is plus 43, this is plus 02, so I suspect that this one grows much bigger. Whoops, no, so then we take this is the next smallest, copy, paste, oh, it didn't even paste it well. Okay, and finally, this one is the largest. This is a big exponential. Copy. Paste. Okay. Anyways, did something wrong there. But anyways, now you can put them in order. Now you have them in order. This is the slowest to the highest. Okay. Now, I just like to, so that's fine. I'd just like to graph these. So let's do this. I want to graph this. So here's how I do it. I go insert. I want to insert a line graph. So you put a line graph. It should be a line graph like this. Now, if you look at it, it's stupid. Okay, because the only thing that grows very fast is this n to the log log. So this is n to the log log. That's an exponential. The others aren't growing fast. Anyways, here's what you do here, because most of the values are below 43. So here's what you do. You format this axis. You click on this axis and you format it, and you make it into what's called a logarithmic scale. Okay, it tells you there's a problem, but you can ignore the problem, and there it has it. Okay, so let's go through this. E to the n is the highest. That's what we had. This is gray, n to the log n. It says that's higher than the brown one. What's the brown one? Log to the n factorial. So we were wrong. Okay, this n to the log n grows faster than log of n factorial. Okay, the green one is n to the third. Okay, that's interesting. Okay, 2 to the log n is this dark blue. Log n factorial is the light blue, and the brown is ln of n. So that's almost down on the bottom. Okay, so this is the way you would order them. Either look at the numbers or make a chart and do that. Okay, so this is a lot of fun. Okay, Windows Shift Q. Okay, so that's the end of chapter 3 homework. I hope you enjoyed it.